Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. We will continue the chapter of circles in class 9 in this lecture also. So in this lecture we will focus on angle subtended by an arc of a circle. Also we will discuss about cyclic quadrilateral a lot, and we will compare the angles subtended by a arc on major segment, minor segment, etc. Okay, so let us start with this topic here. What is an arc? Let us say this is a chord. Okay, we have studied about the chords in previous lectures. So if let us say we have got another circle and these two circles are congruent circles, so their radii are equal. So if it is r, this is also r. Okay, and if I take equal chords, this chord is equal to this chord. What can I say about these arcs? This is minor arc, right? This one is minor arc. So if this is A, this is also A, so these chords are equal. What can I say about these arcs, corresponding minor arcs? These will also be equal. So if we have got two equal chords in two congruent circles, then their corresponding minor arcs will be equal or congruent, you can say, because congruent and equal can be used interchangeably. In geometry, generally we use congruent. So their minor arcs are congruent. Also the corresponding major arcs are also congruent. So this major arc is equal to corresponding major arc of the second circle. Okay, and this will happen in only one circle also. Let us say you have got only one circle, and in this circle this is one chord, this is another chord. Okay, and if I say these chords are equal, then their corresponding arcs, that is this arc, this is minor arc for this chord, and corresponding to this chord I'll have this minor arc. So these will also be equal and their major arcs will also be equal. So equal chords, for equal chords, their corresponding minor arcs and corresponding major arcs are congruent. Okay, now let us move on to an important theorem here. Angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So the question is, let us say this is the center of the circle and I am considering this arc AB. Okay, I am considering this arc here. This arc subtends a certain angle at the center. So what can we say about this angle which this arc subtends on the any other part of the circle, any point on the remaining part of the circle? So let us talk about this angle, okay, and relation between these two angles. So if we have studied about triangles, then we know that, let us say this is a triangle. This angle is an exterior angle to this triangle. It will be equal to sum of opposite interior angles. So if it is alpha, it is beta. This angle here will be equal to alpha plus beta. Exterior angle is equal to sum of interior opposite angles. Now look at this figure here. If I say this is C and this is center O, I am drawing a line CO and I will extend it. So now I got two triangles, one this triangle AOC and this triangle BOC. And if you notice, this angle is exterior to triangle AOC. So it will be equal to interior opposite angles. So if this angle, let us say, is angle 1 and this is angle 2, okay, if this angle is alpha, what will be this angle? Look at this, OC is equal to OA, because both of these segments are radii of the same circle. So this is equal to this. So if this angle is alpha, this angle will also be alpha, because base angles of an isosceles triangle are equal. So what can I say about angle 1? Angle 1 will be equal to alpha plus alpha, that is 2 alpha. Similarly, angle 2 will be equal to sum of this angle and this angle. If I consider them to be beta, because these will also be equal, because OC is equal to OB. OC is also equal to OB because of the same reason. Okay, so base angles are equal in case of isosceles triangles, so both of these are beta. So angle 2 is equal to beta plus beta, that is 2 beta, right? So if I take sum of angle 1 and angle 2, it will be equal to twice of alpha plus beta. And what is alpha plus beta? This is the angle subtended by arc AB at the circle. And what is angle 1 plus angle 2? It is angle subtended by the arc AB at the center of the circle. So angle subtended at the center of the circle is twice the angle subtended at any point on the remaining part of the circle. So we can prove it using the knowledge of exterior angles, right? Now look at this. If, let us say, we have got this diameter, okay. Now if I am considering this arc here, which is nothing but a semicircle, this arc is nothing but a semicircle, and if I ask you what is the angle subtended by this arc, which is semicircle, at the center, you will say this is the angle. And what is this angle? This is a straight angle, that is 180 degrees. This angle is 180 degrees. So what will be the angle subtended by this arc? Let me name this arc by AB. So AB arc. I am talking about arc AB. Arc AB subtends an angle of 180 degree at the center. Let us look at this angle which arc AB subtends at the remaining part of the circle, that is this angle. This angle will obviously be half of 180, hence it will be a right angle. So angle in a semicircle, or we can say angle subtended by the diameter, is equal to 90 degrees, right? You can prove it using the same argument. If you join these points, this will become an exterior angle, right? This angle and this angle are equal because these two sides are equal. Okay, so again you take them alpha, alpha. If you take this as angle 1 will be equal to twice of alpha. So if this is beta, this is beta, this angle 2 will be twice of beta. Hence you can prove that angle 1 plus angle 2, that is 180 degrees, is twice of this angle alpha plus beta. Hence this angle is 90 degrees. So from here we got this point that angle in a semicircle or angle subtended by the diameter is a right angle, that is equal to 90 degrees, right? So we have got two things. Angle subtended by an arc at the center is double the angle subtended by the same arc at the remaining part of the circle. That is, we are talking about this part, anywhere on this part. If it subtends an angle, it will be half of the angle subtended at the center. Okay. We will also talk about this angle, okay, subtended by this chord, but in later questions. Angles in the same segment of a circle are equal. This is very easy for us to observe because we already know that angle subtended at the center by an arc is double of the angle subtended by the same arc at any other part of the remaining circle. So if it is theta, what will be this angle? This will be theta by 2. Okay, because this angle is subtended at the center by arc AB, and this angle is subtended at the remaining part of the circle by arc AB. So it is half of theta, right? So what can you say about this angle? Another angle subtended by arc AB on rest of the circle. It will also be half of this angle theta. So it will also be theta by 2. So these two angles are equal. So angles subtended in the same segment of a circle are equal. Okay, so you can subtend any other angle also. It will also be half of this angle, hence equal to these angles, right? You can keep on subtending angles like this. This angle will also be theta by 2. Okay, so what is the reasoning that you will give? You will mark this point as, let us say, C, and this as C dash. So you will say angle ACB is equal to half of angle AOB, and then you will give the reason that angle subtended at the center is double of the angle subtended at the remaining part of the circle. That is, you will write this theorem here as a reason. Okay, and the second angle you will talk about is angle AC dash B. It is also half of angle AOB by the same reason. So you will write the same theorem here. Okay, now comparing these two equations, you can say angle ACB is equal to angle AC dash B. And for that matter, if you take C double dash, C triple dash, all these angles will be equal because of the same logic. Okay, so collectively we can say angles in the same segment of a circle are equal, right? Now, if a line segment joining two points subtends equal angles at two other points lying on the same side of the line containing the line segment, the 4 points lie on a circle. So let me simplify this for you. Let us say this is the line segment. Okay, and this line segment subtends an angle theta at this point C. Okay, also this line segment subtends the same angle theta at point C dash. This theorem says A, C, C dash, B are concyclic. What does it mean, concyclic? That these points will lie on a circle. So if I want to draw a circle passing through A, B and C, it will also pass through C dash if these angles are equal. So this is the theorem, that if I have got a line segment AB, let us say, and it subtends an angle theta at C and C dash both, then A, B, C, C dash, these points are on a circle. That is, these points are concyclic. So how can you prove it? You can prove it by considering that by contradiction you can prove it. Let us say we have got a point E. Let us say these points do not lie on a circle, and then C dash will either lie outside the circle or inside the circle. If it doesn't lie outside, if it doesn't lie on the circle, then it may lie outside the circle or inside the circle. In that case, if I join these with AB, if I join C dash with A and B, then this angle will be equal to this angle as per the given condition, that it subtends equal angles at two other points, C and C dash. So if this is theta and this is theta, then it cannot be true. Why? Because this angle is also theta for this point lying on the circle, because we already know that angles in the same segment are equal. So it can never be true until and unless this point lies on this point. These 2 points coincide, right? Similar is the case with this point lying outside. So if I consider that this point lies outside, even then this angle will be equal to this angle, but this angle is already equal to this angle because these lies on the same segment of the circle. So this point and this point have to coincide. Okay, so what you can do is you can take you can give them different names. Let us say this is E and this is, let us say, E dash. Okay, so you will take A E dash B and you will say that this is angle theta, but we already know that AC dash B is theta, so C dash and E dash will coincide with each other. So let me write this again for you. So the language of the theorem is, if a line segment joining two points subtends equal angles at two other points lying on the same side of the line. Let us say this is the line segment A, B, and these are 2 points lying on the same side of line segment AB, and AB subtends equal angles at these points. Now the theorem says that if it is true, this much is true, then A, C, C dash B lie on a circle, that is, these vertices are concyclic. By concyclic I mean they lie on the same circle. Okay, so what we know already is that angles in the same segment of a circle are equal. Right, now we can start the proof. Let us say I draw a circle. I need to prove that these points A, B, C and C dash are concyclic. That means if I draw a circle passing through A, B and C, it will necessarily pass through C dash because these angles are equal. Okay, so let us say this circle, the fourth point, let us say there is a point E which doesn't lie on the circle, and angle AEB is equal to angle ACB. Let us say this angle is also theta, but we know because this angle lies in the same segment, angle AC dash B is equal to angle ACB because they lie in the same segment. Okay, this we already know. So let us say there is a point E for which angle AEB is also theta and E lies in the interior of the circle. There can only be three circumstances. Either a point can lie on the circle, or in the interior of the circle, or in the exterior of the circle. Okay, so I am considering all the other 2 points E and E dash being inside and outside the circle, and I'll prove by contradiction that this cannot be true, that if this angle is theta, it will only lie on the circle. So now AEB is equal to theta, but we know that AC dash B is equal to theta. So if these two angles are equal, this can happen only if E and C dash coincide. Now if I take E dash, let us say, outside and say AE dash B is theta, then again by the same logic I'll say AE dash B is equal to theta, which is equal to angle A C dash B, right, which is possible only if E dash and C dash coincide. Okay, so there is only one possibility, that if there is a line segment AB and it subtends equal angles at 2 points lying on the same side of AB, then these 4 points will be concyclic. They will lie on a circle. Okay, the sum of either pair of opposite angles of a cyclic quadrilateral is 180. What is a cyclic quadrilateral? The vertices of which lie on the circle. This is a cyclic quadrilateral. For example, in this case, ABCD is a cyclic quadrilateral as vertices A, B, C and D lie on a circle. Okay, so if any one of the vertex doesn't lie on the circle, then it will not be a cyclic quadrilateral. All four vertices should lie on the circle. Okay, now this is a cyclic quadrilateral, and in a cyclic quadrilateral, sum of opposite angles is equal to 180 degrees. That means angle A plus angle C is equal to 180 degrees. Angle B plus angle D is also equal to 180 degrees. This is the property of cyclic quadrilaterals. We can easily prove it or observe it if we take center as O, let us say. Let me draw this line here and this line, right? So if this is angle theta, let us say, what will be this angle? This will be theta by 2. How? Because I have taken O as center and arc DCB subtends angle theta at the center of the circle. So it will subtend half of theta at the remaining part of the circle. Okay, this we have already discussed in the introduction part. So if it is theta, this will be theta by 2, and by the same logic, if this is alpha, what will be this angle? This will be alpha by 2. Okay, it will be half of the angle subtended at the center by arc DAB. Okay, now we know theta plus alpha is equal to 360 degrees because it is a complete angle around a point. So the sum is 360 degrees. And what will be sum of A and angle C? These are theta by 2 and alpha by 2. So their sum will be half of theta plus alpha, which is 360 by 2, that is 180 degrees. Using the similar argument, you can say that sum of these two angles, angle B and angle D, is also 180. For that, you can join A with O and O with C. Then you show that this angle is double of this angle, and this angle is double of this angle here, right? So sum of this angle and this angle is 360. So their halves will add up to 180 degrees. Okay. So opposite angles of a cyclic quadrilateral are supplementary, or we can say their sum is 180 degrees. Okay. Now using the same concept, we can observe one other thing. Let us say this is a cyclic quadrilateral and I extend one of its sides here. I know that if this angle is theta, then this angle will be 180 minus theta, right? Because opposite angles in a cyclic quadrilateral are supplementary. So what can you say about this exterior angle here? You know that this angle and this angle form a linear pair. So their sum has to be 180. For that, this angle will be equal to theta. I hope you have understood. Otherwise, what you can do is, you can take this angle as alpha. Then you say theta plus alpha is equal to 180 degrees. Okay. You take this angle as beta first. Okay. Then you say by linear pair alpha plus beta is equal to 180 degrees. Right. Now, if I subtract, let us say this equation from this one, then alpha will get cancelled. Theta minus beta will be equal to 180 minus 180, that is 0. So theta will be equal to beta, that is this angle will be equal to exterior angle, this. So if you have got a cyclic quadrilateral, then if you extend one of its sides, this exterior angle here will be equal to opposite interior angle. So if it is alpha, this will also be alpha. If this is beta, this will also be beta. Okay, let us move ahead. If the sum of a pair of opposite angles of a quadrilateral is 180 degrees, then the quadrilateral is cyclic. Now in this case, let us say there is a quadrilateral A, B, C, D. The sum of these two angles is given as 180 degrees. and we need to say that this quadrilateral is cyclic. Okay, so it is given that angle A plus angle C is equal to 180 and angle B plus angle D is equal to 180 degrees. So points A, B, C and D will lie on a circle. Now this theorem can also be proved using the contradiction method. That is, if let us say A plus C is 180, D plus B is also 180, but these points do not lie on a circle. So let me draw a circle first, then we will use a contradictory statement to prove the result. Let us say this is not B for a moment, and B lies inside this circle or outside this circle. Okay, now if I will join these points, then I will say that this angle and this angle is equal to 180 degrees as per the given condition. Okay, and I will consider this point as, let us say, B dash. Okay, and then I'll say D plus angle B dash is also 180 degrees because these are opposite angles of a cyclic quadrilateral, and we have just proved that opposite angles of a cyclic quadrilateral are supplementary. So now these two statements, that angle D plus angle B is 180 and angle D plus angle B dash is 180, these statements can only be true if B and B dash coincide each other. Okay, so using the same method of proving by contradiction, you can say that if the sum of pair of opposite angles of a quadrilateral is 180 degrees, then the quadrilateral is necessarily cyclic. That is, all the four vertices lie on a circle.